Okay, so told you I would put out a video explaining the wiring. Just in case anybody needs to know how this works, I'm going to do this in very layman's terms type thing. I don't expect anybody to be like fluent in electronics diagrams and everything. You don't need to be. You just, if you understand electricity like water flowing through devices and causing little things to happen, we're going to work with that. Okay? And we're going to make this real easy. I put a diagram up and I'm going to draw the lines as we go through some of the explanation here, and I will try to make sure that we're adjusted. These are the pieces that I want. Okay, the two plastic pieces here and here are parts that you print. Okay, this little switch, I didn't pull it out. I'm not going to do that. It's got two wires in the back, and we'll explain. Okay, that's it. You have your PTC heater with fan. Okay, so this is the heater piece. This is the fan. You have wires for your fan. You have wires for your heater. Okay, and then we have our temp controller. Okay, we're going to go ahead and go through this. I went through the explanation on operation of this specific temp controller. Most of them are relatively similar enough that you can figure it out. If not, there's instructions for each one. Essentially, you're just going to press and hold set. You're going to see F1 through F4. You're going to select which one you want. Press S again to adjust it. The first F1 is temperature. F2 is how high or low over or under that when you want it to change, to do its little flipping of the switches. And then the third one is basically a delay in case you were using a compressor. You're not going to really use that. The fourth one is in case you're using a different temperature probe. You're not going to really need that unless they have really crappy equipment and you bought a bad one with a bad temp probe and you need to adjust it and the temperature's off from what it actually is. And then in the case of this one, because it runs Fahrenheit, there's an F5 that you can adjust that. All right. As far as why I purchased this specific one, I like the 110. If you want to get a 12 volt and run it off of a 12 volt adapter, you're going to need some amperage to do that. You're going to need at least 10 amps to run one of these at about 12 volt or more. So it can be a little bit tricky. Again, this one was very nice. I liked it because A, it was 110, and B, it had this cable, which means I can detach this cable and I can put it in. Now here's the thing. The cable that came from here went directly to this heater. And what I did is I gave myself a good 8 inches there. Okay, my hands are at about 8 inches. Gave myself about 8-9 inches of the cable, and that's where I cut it. You then end up with plenty of extra cable. I don't use very large pieces. As you can see here, these are pretty small and short. I use some short ones. I had plenty of wire left over. I also, anytime I'm throwing out a vacuum cleaner or anything like that, those are high amperage type devices. I will cut the cord off and save it as wire. Either that or I'll make an extension cord out of it because those things are rated for 13 to 15 amps minimum. Which means, yeah, they work great for something like this that might pull upwards of a bazillion amps. This isn't going to pull that much amperage. Actually, this I think only pulls about 2, but it's nice to know that you have the current flow and the wire, and it's nice and safe for the type that you need. I would, if you don't do that and you just buy wire, I would go, personally, I'd probably use at least a 16 gauge. If you're looking at it, the stranded is going to be easier because it's going to be flexible, but if you go solid, it's going to be more firm and you bend it and it stays in place. So what we're going to do here is we start off, we're going to look at this as just power. Okay, actually, I'm going to take a quick note to make a mention of this. This is what I mentioned in my previous videos about how I used silicone and then I used paper on the inside. Again, paper is an excellent thermal barrier as long as you're not going, you know, over 450 degrees. And the highest this thing gets is 250. That's running in solid constant heat, no downtime, no nothing. It's just running, so it's not even going to char this paper, but what it's going to do is protect your plastic from melting. So it gives you a nice little barrier. I just threw on some silicone. I wasn't even very careful about it. I just used the silicone as glue, because silicone in and of itself also rated for 450 minimum. Any silicone that you find, whether it's that RTV stuff or the Permatex or anything, just the stuff you get to seal your windows, as long as it's actual silicone, not the latex stuff, it's going to be rated for 450. The hole for your thermal piece, again, you just cut a small hole here so that you can push this through. Once it pushes through, it gets a little difficult to pull back through, but that's fine. Actually, you know what? I'm going to try to do that so I can at least show you what I did with this. I'm actually going to be shortening this cable. I meant to do that, but I didn't do it before I put it together. I was kind of anxious to get it working. Let's go ahead and pull this through. If you are, when you do this, very carefully, this one comes with this waterproof whatever thing, okay? Now, what it's doing is it's testing resistance on here, so you're not going to necessarily want to play with this, and there's a little protective coating on this as well. But basically, I very carefully carved off the rubber from this, and I used basically one of those X-Acto knives, and I just whittled it. I whittled it off until I exposed this piece right here. Okay, let's see if we can get a bigger close-up of that. I whittled it until you can see that little piece right there, because that's what you want to detect the heat. And by doing this, it reduced the wave of up and down between the time when this heated up the air then heated up this. So like I said, there's a bit of a temp variant that you go through with that. You put it through here, and I just use a little bit of caulking to hold it in place. You do not want it to be touching these little vents in here. You can see that, but as you can also see, it comes with a little grating to help prevent it from doing that. If you just pull it back right here so that it's tight up against the wall, you're fine. And everything's good. You're nice and close. It's about a good inch away, but that's fine. It's not horrible. You're doing great. All right. So this helps protect against heat, against the wear. I ran it without this. I did a test where I ran it without it for days, and it got very warm, but it never deformed or anything like that. I ran it at 125. It was fine, but if you're talking about long-term exposure, it's better to not deal with it. Additionally, just for safety purposes, making sure that we're nice and solid, I do that. So that again is part of a safety piece. All right, so let's talk about how power flows through, starting with the power not polarized, meaning there's no ground wire, and it doesn't matter whether this is positive or this is negative. I'm going to declare one as positive and negative just so you can watch through the flow. It just doesn't matter whether we plug it in this way or this way. It's still going to work, okay? It doesn't require that the water flows in the same direction. It just needs to flow. All right, so we're going to provide that power's coming in here, okay? Actually, if you really worry about it and you want to do it to the most safest position, this is the proper way you want to do it. You want power to come in through the switch and then ground coming out or neutral coming out. And what you do is when you plug this in, pay attention to which one goes into the fat hole, because that's your neutral, and which one goes into the skinny hole. You then follow it down the wire. There's one wire on each side. You go, oh, this is plus, this is minus, and then you put it in based on that. If you wanted to memorize all that, you could. I'm not going to take the time because it works either way. And it's plenty safe. Now, the first thing we want to do is we wanted everything to turn on and off when we bring power on. So we ran power through the switch. So the cable, which that plugs into, comes in here. I snipped it, like I said, at about 8 inches. I then gave myself a good 5-6 inches here. You can give yourself some more. This one was a earlier prototype. The newer one I put an arc on the back so you had more room for wire. In here, all the room is underneath. On the other one, it's underneath and in the back. It just makes it easier for you so that you had room for wire. And it was available on the side and didn't make a problem. So cut that off. Now you have a little extra wire. I use some from a vacuum cleaner cable, mostly just because I had it there with me. The wires on this are red and black. You're going to want to carefully cut the wires off on here, and you can see I used heat treat little pieces to cover up the wires again, and I just strung them back on. You need to separate these two wires, the fan from the PTC. When you get this and you cut this off, this one's going to be connected to this one, and this one's going to be connected to this one. You want to cut those, okay, so that you can separate the fan from the heater. Because when the power comes in, I have a Wago here. I used Wagos. And what you're going to do is bring power into here. This is basically going to act as a power block. And you're going to run power to your fan at all times. So whenever you turn the unit on, the fan is on. Whether the heater turns on or off based on the controller, the fan will always be on, either pushing the heat through or cooling the plate back down to what it needs to be. It's going to have that nice fan blowing across the heater all the time. So the first thing we wanted to do on our Wago is we have power coming in from this unit. After it comes through the switch, we have the power coming into our little power block piece here. And again, I have it nice and small. Make sure it's in there tight. This is rated for the 16 gauge. We then have power from the fan. And what I did, as you can see here, I used black and white for power and ground. And you're going to put your fan into the power block. So now the only thing stopping power from getting to the fan is the switch. So power is going to go through here. It's going to go through the switch. And then this one is going to go to the neutral, the return. So now you have a power coming in. You have power coming out. As long as your switch is on, it's going to go in, power the fan, and return back to home. It's going to return back and go to ground. Basically grounding through your breaker to make sure that you don't have shorts and things like that, and checking for the wires. That's why they do that. It's to separate and make sure that things are safe. The next one that we have here is we need to power the heater. And we're going to put that through a temperature controller. On the back of your temperature controller, you have power in and out of the controller. This is what powers the controller itself. So we need to have a power line into the temp controller, and you'll see which one it is on here. We can see that this is for the cooler relay. Okay, and this one's for the heater relay. We're not going to be using a cooler relay. We're just going to be using heat. We then have your power on and off. And then this one right here, this little piece right here, that's that temperature probe. Okay, so as we can see here that we have power, positive and minus. Doesn't, again, these is non-polarized, so it can be either way. It's not, I don't even think they listed here. This one is rated up for 10 amps, so it's nice and capable of handling. It's overkill basically as far as what it can handle. All right, so we're going to run power to the unit, and then we're going to run power out. So now when the switch is on, you have flow all the way in, all the way out. So this unit can now, the lights turn on, but we don't have power to the heater. This is going to control that power. So we're going to run a second power wire to the temp controller to this relay. And that is what controls whether or not the heater is turned on. So the power is coming up to the relay. You're then going to put it through the other side. It doesn't matter which way you do this. It's just a switch. It's an automated switch by the sensor and the computer controls to say, okay, it's reached the temperature that you want. We're going to open or close the connection. It's then going to come out through the other side. You're going to have the power go to the heater, and then you're going to have the heat power come back to the neutral. So we've got 3 lines going out, 3 lines coming back, but before the power comes back from the controller here for the heater, it goes 1 over and then back. Then we also have the 2 lines for the probe that come up for here. And again, it doesn't matter which one you put those in. It uses the power from here to send power check through the probe. So, and it checks the resistance, and when the resistance gets to a certain temperature, or when the temperature gets to a certain point, it changes the resistance, and then it knows what it is because it's just watching the resistance levels. All right, so this unit is also maxed out so that you have 110 or 220. It runs on 110, but you can run up to 220 through it, whatever you need. This is the diagram I'm using, and now that I've pulled it apart, I can shorten this cord, which I really wanted to do. All right. If you really want to see me put some wires together, we can do that. But other than that, that's how you put this together. So for me, I made blue my power lines, and I made the red line, which comes to here, the ground. So we're going to put blue in. Going to make sure it goes in nice. Actually, I want to clean that up a little. Just twist that off. We're going to put that in. Close it up. Give it a nice good tug. Make sure it's tight. That's good. So now I have power coming in from the plug to the power block. Power from here is going to both the fan and to the heater. So we have power going to both. We then have the neutral. Now what are we going to do here? We're going to run this one through the relay. Okay, so we need to run this one through the heater relay to make sure that it's going to only let the water flow. It's only going to let that electricity flow when the relay is open and closed, and that's based on the temperature setting inside. Make sure that's on there tight. Make sure that you're not threaded too much so that it's going to short out on the other. Okay, this is the neutral. Okay. So, you know what? I did that backwards to the way I want it. We want power to come through here first. So we're going to have power. We're going to have power to the relay come in from the main power, like I said in the diagram. That was silly. See? It's easy to mix this stuff up. It would still work, but that would have been backwards from what I just explained to you. So let's go ahead and put power from going to the relay. Is that not snapping? Why is that not snapping? Okay. That's not on there. This is not liking me today. It liked it before. I put a little cover on that so that it would stay. And I don't think it's liking that now. So we're going to take that off and just use a plain wire. Half a second to grab a pair of pliers. Just twist that off. I'm just doing things on the fly. Nope, you get to see my mistakes and everything. I don't care. Because mistakes happen. just going to try to bend this out. Try to salvage the wire. Yep, we're good. See? All right. We'll just use wire. We'll make sure we twist that up good. Make sure it stays in there. See? It's all about making sure you're safe. Make sure it works. Make sure that when you close that, yeah, that's a nice tight fit. Okay, so power to the relay, power to the controller itself. All right, so now we've got power to the relay, power to the controller. Now we have this blue one. So this is the blue line that goes to the heater itself. So we had power going to the unit, so we're powered. We have neutral going back to neutral. We have power going to the relay. It's going to come out of the relay, going to the heater. All right. And then we have the neutrals. So we need to have the neutral from here, which is in this, which comes directly off of this plug. So the neutral here, okay, with the neutral from the heater, the neutral from the fan, and the neutral from the controllers. We need all four of these, okay? And I'm going to grab another Wago block, but that's the last piece, is we just need to put together these four and then shove them on in. Don't forget to put in your temperature gauge and put it on there. Once you do that, slides into place, and then you screw it on. Hope that helps. I'm going to hold this up so that you can see it. I know that's a mess, but that's done for layman purposes. Again, power to the fan, power to the temp controller for itself, power to the relay. Relay to the heater, heater back to neutral. Temp controller powers back to neutral. Fan back to neutral. Everything coming through a switch, so it's all controlled by that. There you go. Hope you enjoyed.